but we wanted to start off by sharing our screen here so you can all see our presentation. So to start us off, what is an eclipse and why do they happen? So eclipses are very special things that happen in our solar system, and they're very rare for us here on Earth. Carly's going to talk about that a little bit in a minute. But what is an eclipse? So here we can see a graphic that shows the position of the Earth, Moon, and Sun as we go around the Sun in different locations. And you can see kind of at the top here and the bottom of this graphic, we can see it's labeled lunar eclipse and solar eclipse. So with the moon and Earth and Sun in a direct line from each other, that's the only time we can really have an eclipse. So when it's a full moon, we can have a solar eclipse. When it is a new moon, we can have a solar eclipse. When it's a full moon, we can have a lunar eclipse. But they can only happen at points labeled nodes. That is the exact location where these three can be in a perfect straight line. Now, the moon's orbit is not perfectly circular and it's not perfectly flat either. So it has about a 5% inclination, which means that sometimes the moon is much too high above the Earth for us to see any shadow from an eclipse, or it is much too low. So things can only really happen very rarely when they are exactly lined up at those node locations. And here we can see the difference between a lunar eclipse and a solar eclipse. So a lunar eclipse will happen when the Earth comes between the Sun and the Moon. And of course, the Earth is much bigger than the Moon. So we are able to block a lot more of the light coming off of the Sun. Lunar eclipses, especially total lunar eclipses, are often known as blood moons, and that is thanks to our atmosphere here on Earth. So our atmosphere loves to scatter away the red light, which is why our atmosphere and our sky looks blue during the day. So it scatters away the red light, and that is the red light we see reflecting off of the moon during a lunar eclipse. But during a solar eclipse, the moon is between the Earth and the Sun, and it is a lot smaller than the Earth, so it has a smaller shadow as well. And something that's really unique about solar and lunar eclipses is that there will always be a lunar eclipse either 2 weeks before or 2 weeks after a solar eclipse, just thanks to that path that the moon takes as it goes around the Earth about every 29 days. So 14 days after a solar eclipse or before, we can also see a lunar eclipse. So that's something to look forward to. I believe a lunar eclipse will be occurring on March 25th that we'll be able to see just a tiny bit of here in New England. But we're not talking about lunar eclipses. Today we are talking about solar eclipses. So what are the different types of solar eclipses and what does that mean? So one that you may have heard a lot of just a few months ago is something called an annular solar eclipse. Now, like I said, the moon, it does not have a perfectly round orbit. So sometimes it is a little bit farther away from the sun. Therefore, it looks smaller in our sky. Now, a little fun fact is that the moon is about 400 times smaller in diameter compared to the sun. And it's also about 400 times closer to the Earth than the sun is, which is why they appear to be very similar sizes in the sky. It's about the same size as your thumbnail if you held your arm completely outstretched in front of you. But during an annular eclipse, it is farther away from the Earth, therefore appears smaller and does not cover the entire surface of the sun. We also call this the ring of fire. And you can see here in this image that that central image of the sun and moon is what we mean when we say an annular eclipse. So it is not completely covering that surface. Therefore, it is not safe to look at with your naked eye or even through a telescope. We're going to talk about safety a little bit later in the presentation as well. But for an annular solar eclipse, you would have to use special safety protection like solar eclipse glasses, solar filters on telescopes, and other things like that. But for April 8th of this year, we are going to be experiencing a total solar eclipse passing across all of North America from Mexico through the United States and into Canada. Now, for a total solar eclipse, the moon is a little bit closer in its orbit to the Earth. Therefore, it covers the entire surface of the sun. And this is what that would look like. So as the moon covers the sun and gets to totality, we will start to see this kind of halo around it, and that is the sun's corona, which we will also talk about a little bit today. So if you have questions about sun science, Carly will mention that in just a bit. But during totality is the only time that you can look at the sun without protection, and only during totality. So even if you are outside the path of totality, like you cannot look at the sun unless you are in that path. And that path is very limited. So normally the path of totality, especially the one crossing the United States, is going to be about 100 miles wide and about 10,000 miles long. So very narrow region to be able to see this. But for the most part, everyone else in the United States outside of totality will experience a partial solar eclipse. And this is the third type of eclipse that we'll talk about. A partial solar eclipse, it's the most common way to see a solar eclipse. And it's any amount covered, any amount of the sun covered by the moon, even if it's 0.1% all the way up to 99.99%. So anything that is less than total will be a partial solar eclipse. And for many of us, it will just look like a little bite has been taken out of the sun. Still very, very exciting to see, but not quite as cool as totality.
And as Amanda had mentioned previously, here on Earth, we are in a very special place. And there are not really many other planets that experience something like a total solar eclipse. For example, we have some images here from Mars. This was taken by the Curiosity rover. And this is an annular eclipse where we can see Mars's moon Phobos passing in front of the sun. So this could be called an annular eclipse, just like we saw the Ring of Fire earlier, or it could also be called a transit. And a transit just means that whatever's passing in front of the sun is going to be smaller. So it's going to be something that's not small enough to fully cover it. So it would be transiting across. So Mars, unfortunately, cannot have a total solar eclipse like we get to experience here, just because its moons are not big enough and they don't have that awesome ratio of the moon being 400 times smaller than the sun, but the sun being 400 times further away. But another planet in our solar system that can experience a total solar eclipse would be Jupiter. So if we could have people on Jupiter, they might experience this because of the Galilean moons. The four biggest moons around Jupiter, Io, Europa, Ganymede, and Callisto, are big enough in the sky from the surface of Jupiter that they would be able to fully block the sun. And sometimes they are even bigger than the sun, so this could also be called an occultation instead of a total solar eclipse. But Jupiter is the only other situation in our solar system where we would be seeing this happen. And this image here is Io, one of those Galilean moons, and its shadow passing over Jupiter. So we have talked about a little bit why it is rare for these solar eclipses to happen. You have to have the moon being, 400 times smaller than the sun, and the sun being 400 times further away. And we also have to take into account the path that the moon takes around Earth. So that path is tipped by about 5 degrees from the ecliptic, or the path that the sun takes through the sky. So most of the times of the year, the moon is either going to be too high in the sky or too low, as Amanda has mentioned previously. So they have to line up, and where those paths line up, those are called nodes. And then we also have to have the right size of the moon. So when the moon is closest to us, we call that perigee, and it appears 14 times larger in our sky than when it is at its furthest point in its orbit, which is called apogee. So this orbit is not circular, it's more of an ellipse. So it has those points where it's closer to us and further away. So to get a total solar eclipse, it needs to be at perigee so that it is nice and big in our sky. And it also has to be right on that right part of the path. So when we think about this, the average time between eclipses that are going to be in the same location, the exact same location, is 375 years. And that's a really long time to wait. It's a really long time to wait for an eclipse. And it's not a very wide path. The average path of a total eclipse is about 300 miles wide. And for our Great American Eclipse, the path ranges between 100 miles and 123 miles wide. So you have to be in a very specific part of the country to experience what is totality.
So we are living now in a time of advanced technology, or at least to us, although people may not see it that way millennia from now, but they'll still be observing eclipses then. So how about going back in time? Can you tell us a bit of eclipse history?
Absolutely. So eclipses have been a huge cause of fear, inspired curiosity, and have been associated with a lot of myths, legends, superstitions throughout history. Even today, a lot of those superstitions persist. Here we have an image that is of one of those Chinese myths. And you'll see this a lot across many cultures around the world, that the sun is appearing to be eaten by something. Here we can see that it is what they would call a fire dog is eating the sun. But in other places in the world, like in Norse mythology, it would be a wolf eating the sun, or in parts of indigenous tribes here in the United States, it is actually a bear eating the sun and taking a bite out of it. So a lot of different places have unique stories that attach to their culture and the things and animals that they see as important, or just see in their ecosystems surrounding them. And a lot of times when people would have these superstitions and myths, when a total eclipse or any eclipse really would come around, they would try to scare away whatever was eating the sun. So for some places, they would take pots and pans and they would bang the pots and pans outside, and eventually the sun would come back. In some Native American and indigenous cultures here, they would shoot flaming arrows at the sun to try and reignite it, because they thought something had taken out the fire from the sun. And it could also be a symbol for a disaster to come, or a bad omen for rulers as well. And we've seen quite a few in written record, especially relating to rulers. But today, some of those myths that still are around, a lot rotate around children and motherhood. So in some cultures in East Asia, a lot of mothers will not go outside during an eclipse of any kind, for fear that it would affect their health or their baby's health. And that is still something that we see, even though we know a lot more about our sun and our moon today. But a lot of these things that we've seen through history, here are a couple of those very interesting dates, rotate around those rulers, like I had said. So one of the very earliest solar eclipses that's been recorded in human history was in 2134 BCE. And it is said that Chinese astronomers failed to predict an eclipse, which meant that their emperor was being put in danger. So these two astronomers were executed because of this. But also we have later on in history, about 3,000 years later, we have on August 2nd, 133. This one is known as King Henry's eclipse, because King Henry I, he died very shortly after an eclipse, and that prompted a wider spread of this superstition that this was a bad omen for a lot of rulers. So all of these weird coincidences that happen do affect people's perception of what is happening, even when we have a little bit more knowledge about the science behind it. And as we've learned across time and studied eclipses more closely, we have gained so much knowledge about not only the sun, but how our universe works as well. In May 15th of 1836, an English astronomer, Francis Baily, he first discovered and described something known as Baily's beads. Now, the moon is not a perfectly flat sphere. It has lots of craters, lots that we can see here from Earth as well. So as the moon crosses in front of the sun during an annular eclipse and a total eclipse, you can see just a tiny amount of sunlight appearing as beads on the very edge of the moon. And something that's even more rare is something called the diamond ring, which is when one little tiny chunk of the sun is visible on that outside edge of the moon. And it makes it look like a beautiful glimmering diamond ring. And then just a few years later, in 1851, the very first image of a solar corona was taken by a Prussian photographer. Now, Carly's going to explain a little bit in a few minutes about what a solar corona is. If you have lots of questions about that, they're very interesting. But one more eclipse that I'd like to mention is May 29th of 1919. Now, this was probably one of the most famous eclipses in recent history. And that is because there was an expedition sent out to Brazil and Africa because this eclipse was passing across South America, across the Atlantic Ocean, and into the very edge of Africa. And during this expedition, their goal was to try to prove Einstein's theory of general relativity. Now, that theory states that with lots of gravity in space, that gravity affects light, space, and time itself through warping. And so they went out, they looked at stars that were near enough to the sun and compared them to images that they had taken months prior at night. And what they saw was exactly what Einstein had predicted. So here we have just a little snippet from a newspaper. This is actually from the New York Times from 1919, spreading the word about how exciting Einstein's theory was and how it was proven. But the second graphic here on the right-hand side is showing us what this theory predicted and what they saw. So you can see that the sun here is kind of bending space-time, kind of like a blanket when you put something on top of a blanket. And we call that a gravitational well. Now, when light moves, it moves in a straight line. It doesn't curve around things, except when we pass it by big gravitational wells. So it diverts the light across and around the edge of that well, so it appears like it's in a slightly different position than it actually is. And this was the very first time they were able to see this in 1919. But thankfully, many studies have been done since. There are lots of telescopes, lots of images, especially the Hubble Space Telescope, James Webb Space Telescope. They have great pictures of this warping that we would experience in the universe, thanks to gravitational wells from the sun and from other objects in our solar system, universe, galaxy, etc. But now that I've talked your ear off all about history and mythology, I'm going to turn it over to Carly, who will talk a little bit about solar science.
And I'm going to start with a little bit of the history of solar science. So my friend on the screen here, his name is Thales, and he was a Greek astronomer in 626 BCE. And Thales, he had this belief that the sun was a ball of dirt on fire. And so that was the running science at the time. They were just making things up based on what they knew here on Earth. You know, that's my favorite thing about astronomy is like we're stuck here on Earth and trying to figure out what's going on off of Earth by just using the things that we know around us. And so Thales believed that the sun was a ball of dirt on fire and really had no idea about how to predict a solar eclipse. But some people do think that he might have been able to give the year to expect a solar eclipse. And then this little quote here says that day all of a sudden changed into night. And this event had been foretold by Thales, who forewarned the Ionians of it, fixing for it the very year in which it took place. The Medes and the Lydians, when they observed this change, ceased fighting, and they were alike anxious to have terms of peace agreed upon. So back in this time, they did not have a great understanding of what the sun was, but they had that fear that Amanda had mentioned earlier about solar eclipses. And then moving forward, we got to Anaxagoras, who was another Greek astronomer, and he believed that the sun was a ball of red hot metal. Again, using something that he knew on Earth to try to describe what he was seeing off of Earth. But one thing that is different between them is that Anaxagoras is the first Greek astronomer to have correctly described what a solar eclipse is. And so this is where we're seeing them start to have an understanding of what an eclipse might be. But now moving forward, we know a lot more about the sun. So we know that the sun makes all of the colors of light, things that we can see, things that we can't see, and it has a very interesting structure. So when we look up at the sun, you don't want to look directly at the sun, but when you look and you see the sunlight out, that light that you are seeing is mostly coming from a layer of the sun that's called the photosphere. And then outside of that, there is the chromosphere, and that has more light that is, it's not as bright as the photosphere, so we aren't going to see it. And then on top of that, there is the corona. So you can think of the corona of being the sun's jacket. It is the outermost layer. And we never get to see it because that photosphere is so bright. The only time that we really get to see the corona is during a total solar eclipse. So that's what makes it so special. And the corona is very interesting. So think about sitting next to a campfire. So when you're sitting next to a campfire and you walk away from it, it gets cooler because you're not near the heat source anymore. But with the sun's corona, the further you get from the sun, the hotter it gets, which doesn't make a lot of sense. So it's something that is very, very interesting. We're still studying the corona in science, and having a chance to get a look at it during a solar eclipse is one of the things that makes a total solar eclipse unbelievable.
Well, 75 days from today, many of us will be able to experience the same phenomena humans have observed with awe for all of our existence. In fact, this year, Chinese New Year, February 10, is the year of the dragon, so it's really appropriate that it's followed by an eclipse. So could you please tell us more about what we can expect on April 8, 2024?
Absolutely. So we'll talk a little bit about the path that it's going to take first. So here we have the whole path of the eclipse. The first contact that it's going to make with land will be on about a 25-mile stretch of beach in Mazatlan, Mexico, before crossing across the United States, up through New England, the very top of New England, and out into New Brunswick, Maine, and finally into Newfoundland and Labrador, before going into the ocean and then being done. Now, thankfully, if you are anywhere in the continental United States, you will see at the very least a partial solar eclipse. How much of that is going to be very dependent on how close you are to totality. And we can see here all of these different bands that are different colors. That shows us how much we'll see. So this nice dark red path here in the center, that is going to be totality. And each section outside of that will decrease by about 10%. So this lighter red color is about 90% or more, then 80% or more, all the way until you get to the very, very edges, the very edge of Canada and Washington. Now, if you live anywhere along these paths, there are some really great maps, and we're going to send all of you some resources after this, resources that we really love and love to look at. And one of these will be this website, which is timeanddate.com. And this is actually an interactive map, so you can find your exact location and figure out how much of this eclipse you're going to be able to see. And not only that, but when it's going to start as well. But for here in New England, we are fairly lucky. All of New England, except the very bottom near Martha's Vineyard and Nantucket, you are going to see at least 90% coverage or totality, depending on where you are. Now, right along the left-hand side is here in Concord, New Hampshire, where we are based and where we are right now. And for us, we'll have about 96% coverage of the sun. But again, Carly's going to go into a little bit more about timelines and what that's going to look like. I just want to show you here the path that it's going to take. But for us here in New England, it's going to be in the mid-afternoon that we should expect this. So a lot of children are going to be just getting out of school, or maybe at an after-school program to experience the eclipse themselves. But we have a lot of really great opportunities to see an almost total or total eclipse here in New England.
So I will pause on this slide for just a second for anybody who wants to take a picture of this, but we'll make sure that you can do this for yourself, because in those resources that Amanda mentioned, there is that link to timeanddate.com. So I've just picked some of the major cities that are along the path of totality here and given you just an idea of the timeline. So for example, if you are somewhere near Austin, Texas, your eclipse, these are all in local time, by the way, your eclipse will begin around 12:17 p.m. and then you'll have totality around 1:36. And that will last for 1 minute and 46 seconds, and your whole eclipse will be over by 2:58 p.m. But you can see that there are some other locations here, such as Buffalo, New York. If you are in Buffalo, New York, you will have totality for 3 minutes and 46 seconds. And that is also later in the day. So the duration of how long you will experience totality has to do with how close you are to the center line of that path of totality that we saw in that map earlier. But there are a lot of major cities and other places along this path where you could go and view this eclipse if you are not already in the path of totality. And then thinking about where you went to school, if you are anywhere in the region still of Williamstown, Massachusetts, there will be 96.39% coverage. And the eclipse will begin in the afternoons. That'll be around 2:13. And it will have a maximum at 3:27 p.m. and then take about another hour to end the eclipse. And we have a very similar time frame here in Concord, New Hampshire, where we are going to, again, be at about 96% coverage and have just about that same timeline. But we will be very close to totality, but not, unfortunately, close enough to take off our glasses and get a good view of the sun. But how can we safely view the eclipse? And why isn't it safe to take off our glasses when we are not in the path of totality? So if you were ever one of those kids who took a magnifying glass outside and tried to catch a piece of paper on fire, we have something in common. But you can think of your eyes just like a magnifying glass. So the lens in the front of your eyes is just like a magnifying glass, but it is in fact about 4 times stronger than a magnifying glass that you can find most children playing with. So you would be concentrating all of that light right in the back of your eyes, and you can burn the backs of your eyes just like you would burn that piece of paper. And so that is why it is not safe to just look up at the sun. Even if we have most of the sun covered, it is still enough to do some damage to your eyes. But if you want to view the eclipse, there are some safe ways to do that, and there are some different tools that you can use. So we have some examples here that you can see. In the middle, there are everybody's go-to solar eclipse glasses. But if you are in a place where you can't get your hands on solar eclipse glasses, you can do something very simple and just make a pinhole camera. So that means that you put a tiny hole in a piece of paper, like you can see right here, and you can use that as a projector to show the light from the sun. And as Amanda mentioned earlier, the light travels in a straight line. So it's going to go through that hole, and then you will be able to project it onto a bigger surface. And something else that you can do if you have a telescope at home, you can see our very last image here. This is called a sun funnel. And that is literally a funnel. And it has a cloth attached to the top that is being used as a screen. So the telescope is projecting that image onto that screen through the funnel. So these are just some tools that you could use to view the eclipse.
And just a little bit about this picture on the left-hand side. That is very similar to what Carly was mentioning about a pinhole camera, except that is just light passing through tiny holes between leaves in a tree that's projecting up onto a house. So I'm not sure how many leaves we'll have in April, especially the beginning of April. But if we have some, this is a great way to see what different types of things you can use to see the eclipse. Now, pinhole cameras are a great one. That is this example over here on the left-hand side, just a very simple hole through a piece of cardstock, reflecting and projecting onto another piece of paper on the ground. You can also make pinhole cameras with cardboard boxes like cereal boxes, oatmeal containers, regular big boxes.
You can use a
tubes.
Ritz cracker.
Yes, Ritz crackers are awesome. Anything that you can find around your house that has small holes. And this could be a really great thing to try at your own home, because maybe you have some really unique items that produce lots of little tiny circles. A lot of people like to use a colander that you would drain things in. But it's just a really great way to simply view the eclipse in a safe way. But there are many different activities that you can do at home, especially if you have maybe grandchildren, nieces, nephews, neighbors that have young children, anyone at all. All of these activities are fun for all ages, but it's even more exciting when you get to have the wonder of a child to help bring that childlike joy out. So we have things like shadow tracing, going out at different times of the day and tracing what your shadow looks like and how it is different based on the position of the sun. That's a great way to help people picture how shadows play into eclipses, as well as construction paper sun prints. Construction paper, if you leave it out in the sun for a couple of hours, it will sun bleach over time, and you can put a variety of fun little trinkets, leaves, flowers, seashells, feathers, anything at all. Even just some handprints that you've taken sunscreen and wiped your hands down and put handprints on that construction paper. You can see just how well your sunscreen works on that paper. But again, we will have lots of resources for activities that you can do at home with your families, friends, and loved ones before the eclipse and on the day, which is very exciting. So next we're going to talk a little bit about the next total solar eclipses that will be happening around the world, here in the United States, as well as here in New England. But one thing I wanted to mention a little bit is something called the Saros cycle of eclipses. Now, the Saros cycle is a very unique cycle that the sun, moon, and earth have. And this was something that was discovered thousands of years ago, that ancient Greek astronomers, ancient Babylonian astronomers have been thinking about and using ever since to predict eclipses. Now, a Saros cycle is a period of about 223 synodic months. Now, that just means a lunar month. So how long it would take to get through one lunar cycle, which is, again, about 29 days. But that is approximately 6,585.3 days, or 18 years, 11 days, and 8 hours. And what's super important about this is that 0.3 at the end of that number there. Because for us here on Earth, when we think of days, we think of it as 24 hours. So when you have 0.3 days, that means that the Earth has turned about a third of the way. So the eclipse is going to be a third of the way over across the Earth every single cycle. And that's what this is showing here, these different eclipses every 18 years or so in different locations. So it would take at least 54 years for an eclipse to happen in the same third of the Earth, which is it's a very long time. But the next total solar eclipse that's going to be happening in the world, that is going to be on August 12th of 2026. So in just a couple more years. And it will not reach into the United States. We'll get the very edge of that eclipse. So maybe 15 to 20% at most of a partial eclipse that we'll see here in the northeast of the United States. But this will go across parts of Europe all the way up into the Arctic Circle. Now, in order for us to wait and see what happens here in the United States, if you don't want to travel to see an eclipse, you will have to wait a very long time, because the next total solar eclipse will not happen until 2044 here in the US again. And this is going to be extremely late at night on the eastern seaboard of the United States. That eastern half there will actually be in nighttime. So the sun will have set. We will not be able to see any amount of an eclipse. But if you live in the western part of the United States, especially in parts of North Dakota and Montana, you might have a chance to see another total solar eclipse on August 22nd into the 23rd of 2044. Very, very hard to see, probably be very close to the horizon for all of those people on that West Coast. But that will be the next one that we'll have here. The following year, we will have another total solar eclipse that passes through the US, but it will pass through the southern portion of the US. So it will pass probably again through Texas, which is very exciting. Texas has been great for eclipses the last few years, and into Florida as well. But if you live in New England and you don't plan on traveling anywhere to see an eclipse, you will have to wait even longer until 2079. May 1st, 2079 will be the next total solar eclipse that passes through New England. And this time it will pass through southern New England. So Rhode Island, Connecticut, Massachusetts, parts of Vermont, New Hampshire, and Maine will experience a total solar eclipse on this day. And it will be very early in the morning. So this eclipse will start just before sunrise, and will be visible to us here at about 7 o'clock in the morning. So we'll get a sunrise, it'll get nice and bright, then it'll get dark again, and then it'll get bright again. So 2 sunrises in a day.
It's perfect because Williams College will be in totality and they'll be able to make their 8 a.m. classes.
Okay, so we're almost to the Q&A part, but just quickly, Williams alumni are an engaged bunch. So how might we view the eclipse with friends and family, and how might we get involved in community efforts related to the Great American Total Eclipse?
Absolutely.
So today is your day to start prepping for April 8th, because there is so much to think about, thinking about engaging your friends and your family with having to be excited about the sun. We see the sun every day, but this is something that's so special that it is worth getting excited about. And if you want to watch the eclipse, but you are not somewhere in totality, or you, unfortunately, if you have bad weather, you can watch a NASA broadcast or a live stream so that you're able to view it from anywhere that you might be in the world. But if you are somewhere where you're in the continental US, where you're going to see parts of this eclipse, whether you're going to get a partial or a total, you can try to find a local event. So typically you can find events like this with schools, libraries, boys and girls clubs, and things like that, so you can get involved in your community. And I have to stress that this is the best way to view an eclipse is with other people, because it is an experience that you don't want to have alone. The atmosphere that happens from watching an eclipse in a group is something that you will wish that you could experience more often. It is so exciting to have everybody look up at the sky at the same time and just be excited about the sun and the planet that we live on. And what else you can do to get involved is you can spread the words. You can tell your friends and your family and all of your loved ones about the eclipse. You can tell them how to view it safely to keep them all safe, and just spread the word and try to get a viewing party going in your town, and you can be the host of it at a local park. So it's really just a day to get out there and enjoy the planet we live on and the sun that keeps us warm.
Great. Well, thank you guys so much.
Oh yeah, absolutely.
There are also some scientific studies that happen during the eclipse. So if you are interested, there are citizen science projects such as the Eclipse Soundscapes, and that is studying the effect that the solar eclipse has on wildlife. So there could be all of a sudden the animals going quiet in your area, but that's something that a citizen science project wants people involved, and they want people to study these things for themselves. So through NASA, you can participate in this, but also local to us up here in New England, Plymouth State University is sending up some weather balloons during the eclipse to study it. And we also have the University of New Hampshire has a program called SWUG, where they are using magnetometers to study Earth's atmosphere during the eclipse, as well as MIT, their Haystack Observatory, is also studying the Earth's atmosphere during the eclipse to see how it behaves. So these are some really interesting things to look forward to hearing the results of. And with that, if you have any questions, we would be happy to take them now. But if you remember something in the future that you wish you could have asked us during this time, please feel free to contact us. And our education email is listed here on the slide. So that's education@starhop.com, and you will get an answer from Amanda and I.